Now I am going to solve this problem with the help of Hanning and Hamming window. That means design an ideal high pass filter with a frequency response so and so. Okay, find the values of h of n, find h of z, plot the magnitude response using Hamming and Hanning window. Let us consider. Is it clear? Okay, after getting the value of ht of n, that means see here, after determining the value of ht of n, after determining the value of ht of n, is it clear? We know that h of n is equal to hg of n into that particular technique. Since the technique here is Hanning window, that's why in the starting itself we have to consider the Hanning window. Whn of n is equal to 0.5 plus 0.5 cos, okay, 2 pi n divided by n minus 1. 2 pi n divided by n minus 1 means 11 minus 1. 11 minus 1 becomes 10. 2 1s are 2 5s are, then it becomes pi n by 5. Minus of n minus 1 by 2 means minus 5 to plus 5. Then I have to find out the values for 0 separately. Then 1 minus 1, 2 minus 2, 3 minus 3, 4 minus 4 and 5 minus 1. Then after that come back here, just multiply these two. Then it becomes h of n. Okay, the remaining process is similar as it is. This becomes the filter coefficients if you observe that. Okay, then frequency response. Okay, then you have to plot. Clear? Then observe this question, Hamming window, 0.54 plus 0.46, then as it is, the except we have to find out here that particular technique, then except that we have to multiply this. This is only the difference present in that. Is it clear? This now come back to the remaining procedure is same, guys. Come back to this type of question. Design a filter with hg of e power j omega is equal to e power minus j3 omega minus pi by 4 less than or omega 0 using a Hamming window with n is equal to 7. Don't forget here the transfer function is equal to, okay, not equal to 1. It becomes e power minus j omega. Clear? Therefore we have to do some shifting. Okay, here we have to shift how much value, n minus 1 by 2, that means 7 minus 1 6 by 2, that becomes 3 value. Is it clear? The remaining procedure as it is, guys. First of all, apply the inverse Fourier transform. Okay, then find out the, here very important one, in the previous one how we have calculated hg of 0 separately, hg of 1 minus 1 2 minus 2 separately, but here hg of 0 1 2 3 4 5 6. Okay, if you observe that 0 6 1 5 2 4 3 we have calculated. Why? Because if once in the transfer function they have given the exponential function, we need not to apply any L'Hospital rule. Directly we can able to find out these values. Then later take the particular technique. Okay, calculate as usual the particular technique, 0 separately, 1 minus 1, 2 minus 2, 3 minus 3. Okay, here very important one is we have to shift. Observe that the causal window response can be obtained by shifting the sequence to right by 3 samples. That means here don't be confused what is meant by shifting here. Whatever may be the value you have at the last, that value you have to consider as a 0 value and the maximum value. That means 0 and 6 becomes 0, then 1 and 5 becomes 0.25, then 2 and 4 becomes the next value 0.75. Okay, then the remaining value becomes 1. Are you clear? That is the only difference. Later h of n is equal to hd of n into omega hn of n for 0 less than or equal to, okay, then 0 6 you have to multiply, 1 5 you have to multiply, 2 4. Since in this question they have said that just design a filter with this using a Hamming window. Is it clear? Here they didn't said that find h of z, plot the magnitude response or frequency response. That's why just enough up to here, up to the filter coefficients using Hanning window. Clear? Okay, thank you very much guys. If you have any doubt, you can ask.